Today, we'll be talking about iterated integrals or double integrals. Let us now start first with this first example. What you're going to do here is to first integrate the inner integrand, which is this, which corresponds to dx. So this would be xy dx with the upper and lower limit of 3 and 1. Since this is corresponding to dx, just treat y as a constant here. And now, the integral of x is simply x squared over 2. And now, plugging in values of 3 on the x, we will first have 3 squared over 2 and subtract this by putting 1 on x. So we'll have 1 raised to the power of 2 over 2. And so this would be equal to 4 multiplied by y. After you're done integrating the inner, let us now focus on the outer integral. So this would be the integral of 4y dy with the upper of limit of 1 and lower limit of 0. Put 4 outside the integral. And now this would be equal to 4 multiplied by y squared over 2. And now solve this. You will have 4 multiplied by 1 raised to the power of 2 minus 2 over 2 subtracted by 0 raised to the power of 2 over 2. This would be equal to 0 simply. And so 4 multiplied by 1/2. The answer here is simply 2. Next example. So we will copy this first. So it will be the integral of dy with the upper limit of square root of 4 minus 3x and lower limit of square root of x. Integrating dy, it would be simply y. And so the value for this would be equal to square root of 4 minus 3x. Subtract this by square root of x. Now, focusing now on the outer integral, you will have this value, the integral of square root of 4 minus 3x minus square root of x multiplied by dx with the upper limit of 1 and lower limit of 0. And now integrating this, let us focus first on this. The integral of 4 minus 3x raised to the power of 1/2. This is simply also the same as square root of 4 minus 3x. Let u here be 4 minus 3x. Du right here now would be negative 3 dx. And so substituting this, you will have the integral of u raised to the power of 1/2 multiplied by du over negative 3. And now put negative 3 outside. So we'll have negative 1/3 the integral of u raised to the power of 1/2 of du. The integral of u raised to the power of 1/2 is u raised to the power of 3/2 over 3 over 2. Now this would be the value for this one. Negative 1/3 this should be 1/3. Multiplied by u right here is 4 minus 3x raised to the power of 3 over 2 over 3/2. And subtract this by the integral of square root of x, which is x raised to the power of 3 over 2 over 3 over 2. And bracket this with the upper limit of 1 and lower limit of 0. Simplifying this, you will have negative 1 third multiplied by 2 thirds of 4 minus 3x raised to the power of 3 halves minus 2 thirds multiplied by x raised to the power of 3 halves. Now, negative 1 third multiplied by 2 third, you will have negative 2 over 9. And so first, substitute 1 into this x value. So you will have negative 2 over 9 multiplied by 4 minus 3. 3 times 1 is simply 3. Minus 2 third. X here is 1 raised to the power of 3 halves. And let's subtract this by putting the value of 0 into these x values now. 4 minus 3 times 0 is simply 0. Minus 2 thirds 0 raised to the power of 3 halves. We'll simplify this even further. So, for this one, 4 minus 3 is 1, so you will have a value of negative 2 over 9 multiplied by 1 raised to the power of 3 over 2. 1 raised to the power of 3 over 2 is simply 1. So this is simply 2 over 9. Subtract this by this. Minus 2 thirds. 1 raised to the power of 3 halves is simply 1. No need to put 1 here now. And now let's focus on this. 4 minus 0 is simply 4. And so, since this is negative and distribute negative, in here you will have a positive 2 over 9 multiplied by 4 raised to the power of 3 over 2. 0 raised to the power of 3 over 2 is 0. And anything that multiplies by 0 is simply 0. And now, when you put this into a calculator, the final answer right here would be 8 over 9. Let us now start with this one. So focus on the inner first. So we'll have the integral of e raised to the power of x over y of dx. And so let u here be x over y, and du right here will be equal to 1 over y dx. Keep in mind that y is a constant here. You will not change anything in here. So this is simply 1 over y of dx. And so dx right here would be equal to y du. So this would be the integral of eu multiplied by y du. The integral of eu is simply e raised to the power of u. No need to change anything. And substitute u back into its original form, which is x over y. And substitute y cube into the x value first. So this would be e raised to the power of y cube over y, subtracted by 0, putting the value in x. Wait, this should be y. And now, answer right here would be e raised to the power of y squared minus e raised to the power of 0 is simply 1. And now for the outer integral, you will have the integral of distribute y. So we'll have ye raised to the power of y squared minus y of dy with the upper limit of 1 and lower limit of 0. Now, first we will integrate this one. This would be ye raised to the power of y squared of dy. Let u here be y squared. So du right here would be 2y dy. And now dy right here would be equal to du over 2y. Substitute this into the integral. It would be ye raised to the power of u and multiply this by dy, which is du over 2y. Simplify this. Y here would cancel and the 2 here would go outside the integral. So it would be 1/2 the integral of eu du. And we know that the integral of eu is simply eu. Or 1/2 multiplied by e raised to the power of value of u, which is y squared. And so this is the answer for this integral right here. And so it would be 1/2 multiplied by e raised to the power of y squared. And now let us focus on the integral of negative y. The integral of this is y squared over 2. And now let us bracket this with the upper limit of 1 and lower limit of 0. Let me just make some space here. And now substitute 1 first into the y values. You will have 1/2 e raised to the power of y, which is 1 squared, minus 1 squared over 2. Subtract this by putting 0 on the y values. You will have 1/2 e raised to the power of 0 squared, minus 0 squared over 2. Now, let us simplify this first. 1/2 multiplied by e raised to the power of 1 raised to the power of 2. 1 raised to the power of 2 is simply 1. And so this would be 1/2 e. Let's focus on here. It would be negative 1/2. And now let us focus this next. 1/2 e raised to the power of 0. E raised to the power of 0 is simply 1. So this is simply negative 1/2. And anything that divides by 0 is simply 0. So this would be the remaining answer. And now, the final answer right here, or the simplified answer, would be 1/2 e. Negative 1/2 minus 1/2, it is simply negative 1. Let us now try some applications of double integration. Find the area bounded by y equals 3x and y equals x squared by double integration. X squared. And so what we're going to do first here is to find the intersection points. And so equate this to each other, so it would be 3x equal to x squared. And so x squared would be, x squared minus 3x, it would be equal to 0. Factor x here, which would be x multiplied by x minus 3. And so x right here would be equal to 0 and x would be equal to 3. Substitute 0 into either of these. And so if x is 0, y would be equal to 0. And if x is 3, y here would be equal to 9. So the intersection points is 0 and 0 and 3 and value of 9. And so let us first try to graph this. I will try to make this as accurate as possible. Now, if you can visualize graph this, you can use the table method. For y equals 3x, let's try to put some values of x. If any case x is 1, so 3 multiplied by 1 is 3. And if x is 2, 3 times 2 is 6. If x is 3, 3 times 3 would be equal to 9. And let us try now y equals x squared. So make x and y table again. If x is 1, y here is 1. If x is 2, y it would be 4. And if x is 3, 3 squared is 9. And so let us now plot these points and graph it. So for this, x is 1 and y is 3, 2 and 6, and 3 and 9. So it would be like this. That's some terrible lining. Good enough. Anyway, it is like that. And now for the graph of y equals x squared, this is a parabola. So 1 to 1, 2 and 4, and 3 and 9. So it will intersect this 3 and 9, which is this, which proves our calculation is correct. So it would be like this. Anyway, that is our graph. Y here, the green line here is y equals x squared. And the blue line corresponds to y equals 3x. And now that we have our graphs, there are two ways to try to find the area of this curve. You will find this. This is the area wherein you want to. This is the area where you will want to find. And so, first, there are two ways. It is either using a vertical line or horizontal. Let us try first with the vertical line. And so, try to take a slice of it. So it's like that. And so, visualizing this graph, this is now corresponding to dy. And so, this would be y upper and y lower, wherein y upper here corresponds to this blue line, which is 3x, and y lower corresponds to this green line, which is x squared. And so, area right here, it would be, let's start with the dx. Whenever you correspond to dx, find the x value here, which is 3. And the least value, which is 0. Or you can just base it on here. And integrate this by the upper line, which is 3x. and by the lower, which is x squared. Integrate this by dy dx. And so area right here, the integral of dy, it would be simply y, with the upper limit of 3x and lower limit of x squared of dx. And so replacing 3x and x squared within the y, it would be 3x minus x squared of dx. And so integrating this, it would be the integral of 3x is 3x squared over 2 minus the integral of x squared is x cubed over 3 with the upper limit of 3 and lower limit of 0. So the area right here, 3 multiplied by 3 squared over 2 minus 3 raised to the power of 3 over 3. Subtract this by the 0. We all know this is equal to 0, so we neglect this. So 3, this would be 3 squared is 9, multiplied by 3 is 27 over 2 minus 3 times 3 times 3, it is 27 also over 3. So now calculating this would equal to 9 over 2 square units. This is the area now.